that you settle
Good day, we
down.
are Pro Unique and myself, and we would like to show to you all about our mini project of mass transfer, which about gas absorption pet column. Gas absorption, or we know as a scrubbing, is an operation where a gas mixture is connect with a liquid for the purpose of dissolving one or more component of the gas mixture and to provide a solution of them in the liquid. This means that there are mass transfer of the component of the gas from the gas phase to the liquid phase. In the gas absorption experiment is to operate vapor liquid separation experiment using PET column and the gas absorption process unit. In this process of gas absorption, a, a soluble component is absorbed by mixing it with a liquid phase in which the component is soluble. The system is used for the scrubbing gas stream of carbon dioxide component in this experiment. So the objective of this experiment is one, to operate vapor liquid separation process using the PET column gas absorption process unit. The second one is to analyze the sample using the method of direct titration in order to determine the amount of unreacted sodium dihydroxide NaO in the sample. And the last one objective is to calculate the percentage of the carbon dioxide removed in these explorations.
Next, we proceed to this experimental procedure. In this experiment, we have four parts. This is part A, part B, part C, and part D. For part A, it is a chemical preparation. We use 0.01 mole sodium hydroxide and 0.6 of static solution of 1 liter. For part B, it is the general start procedure. Like usual, before we start experiment, we must ensure the bulb the close or open, check mark, adjust the bulb, and lastly, we turn on the power supply. For part C, we ensure that water flow rate is stable about 10 minutes. This is a important part. After steady state reach, set CO2 flow rate by open bulb FCB2 until CO2 rate is 2 liter per minute. And then we repeat this experiment with 60 liter per minute air flow rate.
Okay. To dilute 0.01 molar of hydrochloric acid in 1 liter. The procedure, firstly, pour 10 ml of hydrochloric acid from the container to the 50 ml of beaker and pipette 10 ml of solution of hydrochloric acid into 1 liter volumetric flask. Then added the ionized water into the volumetric flask up to the mark. The solution for a while until it's homogeneous. Okay. Now, to dilute 0.01 molar of sodium hydroxide in 1 liter, firstly, weigh 0.4 gram of sodium hydroxide pellet and pour into 100 ml beaker, then added the deionized water and stir it to dissolve the sodium hydroxide pellet into homogeneous solution. Pour the dissolved the sodium hydroxide pellet into 1 liter of volumetric flask, and then add the deionized water up to the market level and Shake the solution for a while until it is homogeneous. Next part is to analyze the sample using the method of direct titration in order to determine the amount of unreacted sodium hydroxide in the sample. Firstly, fill the 0.01 molar hydrochloric acid into 50 ml burette. That is pipette 10 ml of sample into 250 ml conical flask. Then pipette 30 ml of solution 0.01 molar sodium hydroxide into 250 ml conical flask that's containing 10 ml of sample. After that, add 1 until 5 drops of indicator, which is phenolphthalein, to the solution. Is titrate the mixture with 0.01 molar hydrochloric acid solution. Then stop titration process once the solution turns to permanent pale pink appear. This is meant to determine the amount of unreacted sodium hydroxide with carbon dioxide in the sample mixture. Accurate result. Repeat the process every 5 minutes until concentration of sodium hydroxide is constant.
Concentration of carbon dioxide and upgrade. So as you can see, this is a packed column, and at the top of the package is the inlet for water, while at the bottom of the package is the inlet for the concentration of carbon dioxide and air. Carbon dioxide gas and air. Okay, and then so we will continue with the reaction. In the packed column, there's two reactions that occurs, which is the first one where the sodium hydroxide and the carbon dioxide gas will produce sodium carbonate and oxygen water. While the second reaction is between sodium carbonate and also hydrochloric acid that will produce carbon dioxide gas, water, and also hydrochloric acid. Next, we'll be moving on with the reaction that occurs in the packed column. There's 2 moles of sodium hydroxide that will result with 1 mole of carbon dioxide gas. Okay, so we assume that X that equal to mole of sodium hydroxide added, which is 0.01 V1. Right, so V1 is on the procedure that has been mentioned before. Is the ml that is also equals to 0.03 liter. Then we put in the equation that will result in 0.01 times with 0.03 liter. That will result in this answer. Then we move on, let y is equal to mole of hydrochloric acid, which is 0.01 V. And the final answer will be 2.16 times with 10 to the power of negative 4 whole.
Also 0.5 times x minus y over the volume of CO2 sample, and we will get this answer. As we continue with the next calculation, to determine the concentration of CO2 at inlet. CO2 inlet stream is equal to 2.0 liter over minute times 5 minutes equals to 10 liter. or equals to 0.01 meter square. So this is the molar mass of CO2 and the density of CO2. Thus, we want to get the mass of CO2. The formula is density times volume. 1.98 kilogram over meter cube times 0.01 meter cube. And we will get the answer in gram, 19.8 gram. Next, we will get the mole of CO2. Mass times mass of CO2 divided by molar mass of CO2. And we will get 0.45 mole. To get the concentration of CO2, we take the mole of CO2 divided by volume. So we will get this answer 0.045 mole over liter.
I would like to conclude about this gas absorption process. In this conclusion, there are two main important points that can be highlighted. The first point, it can comes from this simple equation. From this equation, we know that in gas absorption, mass is transferred from the gas phase to the liquid phase. Gas absorption is actually the unit of pressure in which one or more soluble components of a gas mixture are dissolved in a liquid. The liquid phase is immiscible in the gas phase. Therefore, the liquid phase will vaporize very slightly in the gas phase. Gas absorption is actually interact with the liquid stream flowing counter current, leave as gas from the top. For the second point, we know that gas that contain solute is introduced as feed at the bottom of the column. As the gas with the solute going up the column, the amount of solute will decrease because mass transfer process has happened. The solute has been absorbed by the inert liquid that has been introduced at the top of the column. As the liquid going down the column, the amount of solute content in liquid phase will increase. Well, that's how we conclude about this gas absorption process. That's all from us. Have a good day and thank you.